Balloon 7-2 in-flight maneuvers. Let's delve into the intricate artistry of balloon flight, a realm where precision, regulatory finesse, and a touch of poetry intertwine. Our topic today, one that captivates both the seasoned aeronaut and the curious onlooker, is none other than the sublime dance of the balloon as it gracefully engages in contour flying. Now, to grasp the essence of contour flying, we must first acquaint ourselves with the symphony of regulations, a melody composed by the Federal Aviation Administration in 14 CFR Part 91, Section 91-119. Picture, if you will, the regulatory canvas that delineates the boundaries of our aerial choreography. In the overture, as we soar over congested areas, cities, towns, and the bustling tapestry of human settlements, the maestro, or rather the pilot, must command an altitude of 1,000 feet above the highest obstacle within a 2,000-foot radius. A meticulous navigation, ensuring an emergency landing sans undue hazard, becomes our guiding principle. Yet, as we traverse the less trodden skies over other than congested areas, a distinct cadence emerges, maintaining a minimum altitude of 500 feet above the Earth's surface, with a cautious radius of 500 feet from persons, vessels, vehicles, and structures. We embark on an aerial ballet where safety and consideration waltz hand in hand. But my esteemed audience, the true spectacle lies in the execution, the practice of contour flying itself. Imagine, if you will, the skilled aeronaut navigating at low altitudes, gracefully skimming over trees, descending behind orchards, and mirroring the undulating contours of nature itself. In the heart of this performance, the pilot assumes the role of both artist and engineer. The mental calculus involved in identifying and memorizing obstacles, estimating terrain heights, and anticipating the unexpected resonates with the meticulous strokes of a maestro's baton. Contour flying, dear audience, is a continuous cycle of spatial awareness, a harmony of altitude control and environmental vigilance. The complexities unfold further as we consider wind gusts, shear, thermal dynamics, and the unique orographic conditions that paint the skies. The pilot, our virtuoso, must factor in these nuances, orchestrating a ballet that allows for the free yet disciplined movement of the balloon. And as we soar through this aerial ballet with each burn akin to a note on a sheet of music, the pilot's observation and judgment become paramount. Facing the direction of travel, the pilot turns only their head, a maestro's gaze fixed upon the horizon, scanning for obstacles, observing the movement of power lines, and deciphering the language of the wind. Now let us shift our focus to the nuances of contour flying, exploring cautionary notes and the instrumental symphony that guides the skilled aeronaut through this intricate dance in the skies. In the delicate choreography of contour flying, caution must be our guiding principle. The thin line that separates the sublime from the misunderstood can sometimes be as delicate as gossamer. Allow me to paint a scenario for your consideration. The descent to an intended landing site, an open field beckoning, and yet an unforeseen wind shift leads the balloon astray. It turns toward a farmhouse, a spectacle that may be misinterpreted as rudeness or inconsideration. The experienced eye discerns the miscalculation, the need for an aborted landing. But to the untrained observer, it might appear as a boisterous swoop towards the dwelling. This, dear audience, is a cautionary tale of aborted landings misread as buzzing or impolite maneuvering. Consider for a moment the farmer witnessing the balloon's descent, the burners roaring, only to witness a sudden ascent. The pilot, not inconsiderate but inexperienced, could have averted this misunderstanding. Yet in the realm of contour flying, where the canvas of the sky is painted with calculated descents and aerial ballets, there exists a fine line between the legal, the exhilarating, and the hazardous. Buzzing houses, a term coined for flying too close to structures for thrills, is not only illegal but can also be perilous. Aborted landings mistaken for impromptu aerobatics may lead to unwarranted concern from onlookers. Instruments, our loyal companions in the cockpit, beckon for attention. While regulations mandate their presence and use, seasoned pilots often find themselves relying more on the dance of the wind and the visual symphony outside the basket. The experienced aeronaut, akin to a maestro attuned to an orchestral performance, occasionally glances at the altimeter and the vertical speed indicator, but their mastery lies in the visceral connection with the elements. As we navigate the skies, let us not forget the specter of emergencies, albeit rare in the realm of hot air balloons. In this serene simplicity, our potential emergencies align with the fundamental elements of our craft. Loss or malfunction of the vent or deflation line, loss or malfunction of the pilot light, and the ominous specter of a fuel leak. Loss of control, whether in the form of a vent malfunction or a deflation line mishap, demands a swift yet composed response. The pilot, with limited control, must execute a descent with utmost precision. Minimal altitudes must be maintained, and landings, though challenging, must be executed in the largest available area. In the face of high winds, the seasoned aeronaut anticipates rebound and potential dragging after touchdown, weighing the choice of landing location with meticulous consideration. In the grand tapestry of balloon flight, contour flying unfolds as a mesmerizing ballet where caution, skill, and adherence to regulations compose the delicate melody. As we soar through the skies, let the cautionary notes guide our path, and may our flights be not just an aerial spectacle, but a testament to the artistry of responsible aeronautics. Now, let us delve into the realm of potential challenges that may arise amidst the gentle embrace of the sky, a domain where even the most serene flight can encounter tribulations. We shall explore the intricacies of responding to the loss or malfunction of the pilot light and the ominous specter of a fuel leak. In the cosmic ballet of balloon flight, the pilot light, a faithful companion to our burners, occasionally falters. This can be attributed to a variety of factors, ranging from valve malfunctions to the insidious intrusion of contaminants into the pilot light's orifice. In the realm of dual burner systems, the extinguishing of one pilot light is a manageable hurdle, for the other burner can assume control. The skilled pilot, with a touch of finesse, may attempt to reignite the extinguished pilot light using both burners concurrently. This delicate maneuver, if successful, allows the balloon to gracefully continue its journey until a suitable landing spot is found. However, in the solitary dance of a single burner balloon, the dimming of the pilot light sparks greater concern. With reduced options for continued flight, the pilot must swiftly act to rekindle the flame. A piezoelectric igniter, if equipped, or a striker becomes the instrument of re-illumination. The practiced hand of the pilot, tested during periodic drills and flight reviews, must spring into action. Should the pilot light resist immediate revival, a judicious cracking of the main blast valve, coupled with the ignition of the fuel stream, may salvage the situation. Yet prudence calls for a prompt descent, making solid ground the stage for further assessment and resolution. Now let us cast our gaze upon the foreboding scenario of a fuel leak, a disturbance that echoes with the potential for catastrophic consequences. The design intricacies of balloon fuel systems render numerous junctures vulnerable to leaks. Fuel lines, fittings, tank valves, and blast valves, all potential points of compromise. A vigilant pilot must be cognizant of these vulnerable junctures and poised to respond decisively. In the event of a fuel leak, the pilot's immediate course of action lies in stemming the flow by shutting off the fuel source. The potential menace of small fires ignited by leaks around fittings may be quelled by the swift act of extinguishing the fuel source and employing a gloved hand to smother the flames before they can unleash havoc. Given the diversity in balloon systems, valve types, and operational nuances, each pilot must acquaint themselves with the specific emergency procedures outlined in their balloon's flight manual. The information shared here serves as a general guide, a compass to navigate through the complexities, but it is not a blueprint for every circumstance. The manufacturer's flight manual stands as the authoritative text, offering tailored guidance. In moments of crisis, where the celestial harmony is disrupted, the pilot's unwavering command of the balloon is paramount. The potential escalation of minor issues into major threats underscores the critical importance of continuing to navigate the skies even as challenges unfold. While checklists have their place, in-flight emergencies demand immediate resolution with reference to the manual only after the situation is stabilized. Thus, in the face of adversity, the skilled aeronaut, like a maestro orchestrating a symphony, maintains control, ensuring that the celestial dance endures.